I graduated from Texas University with a Bachelor of Science in Petroleum Engineering in 1948 and was working for the Western Company of North America in various places, but at the time I invented the ball sealers, I was district manager in Borger in 1953. Gas, by the way, was selling for 3 cents a thousand if you could get someone to take it. But some enterprising company set casing through the brown dolomite west of town, which was an 800-foot section, gross section, and they perforated it, 14 zones, 6 shots per foot, a total of 3,000. It's 500 feet of 6 shots per foot, a total of 3,000 half-inch bullet perforations. Really old-timey stuff. Anyway, we went out to acidize the well, and it was bale dry, very low pressure area. We got up to 700 pounds plus 1,000 pounds of hydrostatic head, and the well broke down, and I came away certain that we had only broken down 15 or 20 at the most perforations of the 3,000. And I thought, well, we've left 98% of the gas in the ground. Surely there's a better way to do this than this. I had spent my first 5 years trying to get oil and gas out of the hard rocks, and certainly this wasn't getting the work done. So I went down to the dime store in Borger, Texas, bought 40 jack balls, sponge rubber balls, like the kind that kids play jacks with, and a package of marbles, and 2 or 3 of us around the office dug the inside of the jack balls out and put a marble in there. Then we tested it with an apparatus I put in the built on the yard, and it was obvious that the ball sealers would follow the flow of the water or whatever, acid or whatever you had, and seal the perforations wherever it was going, so the fluid would then have to go to the other perforations, the harder ones, to break down. And you could, in fact, it was obvious you could, in fact, and countless people did, they would keep putting ball sealers in the wells until they balled it out and stopped the flow. And then you'd reverse the flow and the ball sealers would drop off, and then you continue your acid or frac job. Well, anyway, then all kinds of modifications and fine-tuning came from the perforating procedures, picking longer blanks and fewer perforations, and all told, fewer perforations and more of a trend toward isolating the porous zones, leaving the blanks longer to cut down communication between zones. And then the ball sealers really came into prominence, and they have, over these 55 years now they've been in operation, have contributed several hundred billion dollars worth of oil and gas to the world, and they will continue to. They're a very simple process. It just can't get any more simple than that, and it's here to stay. It's public domain. Exxon has recently invented a modification or an elaboration, let's put it, of that system, and fracked 50 zones per well in that massive Mesa Verde on the western slope of the Rockies called the Piceance Basin. And now they say they can recover and will recover over decades 45 trillion feet of gas worth $250 billion and approximately 2.5 years supply of gas for the United States. This is a massive, and they do it without a rig over the hole for any of the completion. They frack 11 zones without stopping the pumps. It's a brilliant, absolutely brilliant application of the old ball sealer invention, and it's a massive contribution to the United States and our ability to be independent, or more and more independent, of foreign sources. For that reason, I am indeed proud of my part in helping recover the oil from the hard rocks, what one fellow called the reluctant rocks. And believe me, some of them are plenty reluctant. Thank you. I'm proud to be a graduate of the University of Texas, and have had an opportunity to serve as chairman of the Engineering Foundation back in '83 and '84. And believe me, I'll always remember where I came from. Thank you.